What if the night sky were less a backdrop and more a letter, quietly slipped under the door of our attention? You see, on November 5th, 2025, Loeb posted a fresh analysis that reads like one of those letters. He turned his eye to an interstellar visitor, the object we call 3I Atlas, and asked a wonderfully awkward question: why is it behaving as if the script of comets were only a first draft? In the days just after its close brush with the Sun, data gathered from planetary trackers showed the object brightening by nearly a factor of 5 in a green band, as though some hidden engine had opened its shutters. And, that is not what a typical comet does after perihelion. Loeb noted a small but stubborn push in its trajectory, a non-gravitational nudge that should, if driven by ordinary outgassing, demand a great price in lost mass. If the price had been paid, we would expect a grand, whispering veil of gas and dust, a visible confession hanging around the nucleus. But the veil did not appear. So perhaps, well, the question becomes less about the object and more about us. Do we truly know the habits of interstellar ice and rock, or have we domesticated comets in our minds, made them tidier than they are? Imagine time here as a landscape rather than a clock, and this traveller as a footprint crossing it. Between October's end and early November, the footprint deepened, then slid sideways in a way that should not happen without a gale. Yet, the gale is invisible. And that's the thing. Sometimes the absence of a thing is the loudest signal in the room. Are we witnessing the edge of a law, or the beginning of a new map? Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us, from all around the world. So let's continue. Of all the strange things about 3I Atlas, perhaps the strangest is its path, the way it moves, the way it insists on being different. You see, in the language of the heavens, motion is everything. The orbit of a body is not just a line in space. It's a story, a record of every pull, every encounter, every whisper of gravity it has ever known. And 3I Atlas, well, its story doesn't read like anything we've seen before. It travels backward, retrograde, moving opposite to the grand, sweeping current of our solar system, and yet its orbit lies almost perfectly along the same flat plane where all the planets circle the Sunday. That's a contradiction, a cosmic paradox in motion. Objects from beyond our solar system almost never do that. The probability, according to Loeb's calculations, is just about 2 in 1,000. So, when he first noticed it, on that cool November evening in 2025, he didn't shout discovery, he simply whispered, "That's odd." And that, is where science begins. You see, when something breaks the pattern, it doesn't necessarily break the law, it reveals the limits of what the law describes. For 3I Atlas, the limits were drawn by expectation. Every comet we've known, from Halley's ghostly returns to the icy wanderers of the Oort cloud, follows the script of gravity with predictable elegance. They fall in steeply, slice through the solar system's disk, and vanish back into the dark. But 3I Atlas? It skims the ecliptic like a stone skipping across water, graceful, balanced, almost intentional. And, that's what caught Loeb's attention. Because geometry, in the universe, doesn't happen by accident, not when it's this precise. The ecliptic plane, that thin, glowing highway of planets and dust, is like the solar system's equator. For something arriving from the stars to slip almost perfectly into that plane is like throwing a dart across light years and landing it on a single thread. You'd need an alignment of forces so improbable that, well, coincidence begins to sound like design. But design of what? And by whom or what? Now, before imagination takes the wheel, Loeb reminds us, it's not about aliens or machines, it's about the physics of arrival. How could an interstellar object find itself moving so smoothly along our planetary plane? Perhaps, it passed through regions of space where the galactic gravitational field gently sculpted its motion. Perhaps repeated nudges from stellar tides flattened its orbit, ironing out the chaos. Or perhaps, and this is the thought that lingers, perhaps there are unseen structures out there, great cosmic rivers that guide travelers through the galaxy, like ocean currents guide drifting ships. That image stayed with him, invisible lanes of motion stretching between stars. And when you think about it, it's not impossible. Space, though vast, is not uniform. Gravity pools and eddies, light bends, dust collects, and through it all, bodies drift, pulled by subtle harmonies we barely perceive. If 3I Atlas followed one of these paths, then its improbable orbit may not be an accident, but an echo of those deeper galactic patterns. Still, something about it feels, well, personal. Because in the delicate dance of orbital mechanics, everything is supposed to add up. Yet this object, this quiet traveler, seems to know steps we don't. It's retrograde but planar, foreign but familiar, fast but poised. When plotted on NASA's JPL charts, its trajectory threads elegantly between the orbits of Venus and Mars, like it's tracing the seam between the inner and outer solar system. Too close to call chance, too exact to dismiss. Loeb often says that anomalies are the universe's way of talking to us. Most of us just don't listen long enough. And perhaps that's the point, not to solve the mystery too quickly, but to hold it, to let it unfold. Because when we stare at that orbit, when we see how it mirrors our own planetary geometry while moving against the flow, something inside us stirs. We begin to feel, that subtle recognition. Maybe the laws of nature are not just rigid equations, but living patterns that can surprise even themselves. So let's look more closely. A retrograde orbit means it moves clockwise when viewed from above the Sun's north pole, opposite to almost everything else. But the inclination, the tilt of its path relative to the solar system's plane, is small, less than 10 degrees off. That's remarkable. If it had entered at a steep angle, we'd call it typical, a random visitor just passing through. But because it stays so close to our planetary highway, we can track it longer, watch it interact with sunlight, gravity, and perhaps even magnetic fields. There's another layer here, something, poetic. You see, retrograde motion isn't rebellion, it's reflection. When something moves opposite the flow, it mirrors the system that birthed it. It tells us about symmetry, about the possibility that for every forward there is a backward, for every starborn path, a returning one. Maybe 3I Atlas is the echo of another system, a world that spun the other way, orbiting a sun we'll never see. That thought makes the night sky feel smaller, not in distance, but in intimacy. Because suddenly, that faint streak of light isn't just a traveler, it's a messenger from a mirror version of cosmic order. When Loeb mapped its path backward through time, he found no clear parent system, no stellar nursery, no obvious point of origin. The orbit simply dissolves into the galactic background, as if it has been wandering for eons. That timelessness, that sense of drift, gives it an almost mythic quality. It's as if 3I Atlas has been circling the galaxy long enough to forget where it came from, yet somehow it found its way to us precisely, improbably, elegantly. And that precision raises questions. You see, if we assume pure gravitational interaction, the odds of such alignment are vanishingly low. So, either there's a new kind of scattering mechanism in interstellar space, or, there's something in the dynamics of entry we don't yet understand. Perhaps the very act of crossing into a star's gravitational sphere compresses the trajectory, forcing it toward the system's plane, like a funnel, like a gate. And that word gate resonates strangely, because it suggests transition, transformation. Once the object entered our domain, its motion changed character, became more orderly, not random, but responsive. Could our solar system be shaping the paths of visitors before we even notice them? Could there be a subtle alignment force, perhaps gravitational, perhaps electromagnetic, that herds incoming bodies into this narrow region of balance? We don't know. But the idea stirs something both scientific and, well, deeply human. Because if even one interstellar traveler follows a path so elegant, so deliberate, it means the universe itself might favor harmony. Loeb, of course, stays grounded in data. He measures the elements, the eccentricity, the argument of perihelion, all the mathematical poetry that describes an orbit. And each number seems to whisper the same message, improbable, yet consistent. The retrograde nature tells us it came from elsewhere. The near-zero inclination tells us it belongs, for a moment to hear. It's not just a visitor. It's a participant part of the solar system's ongoing dialogue with the galaxy. And perhaps, that's what makes this so profound. It's not about whether the object is artificial or natural. It's about the realization that boundaries between systems, between randomness and intention, may be thinner than we think. So, as 3I Atlas loops past the Sun and begins its long climb outward, we're left tracing its line against the ecliptic, wondering what invisible forces guided it here. Was it sculpted by chaos or drawn by resonance? Was its orbit the result of chance or of a deeper structure we haven't yet mapped? The thing about questions like these is that they don't close, they expand. They remind us that motion itself is a form of memory, that every orbit carries the imprint of where it has been. And maybe, just maybe, 3I Atlas is showing us that the galaxy's memory runs through us all. So we stand here, on this small blue planet, gazing upward, watching that faint arc of light trace the edge of the known and the unknown. We measure its speed, its tilt, its fading glow. But what we're really measuring is our own astonishment. Because, in the symmetry of its motion, there's a quiet message. Nothing travels alone. And as the comet drifts beyond Mars, threading close to the orbital paths of Venus and Jupiter, a path so improbably refined that the odds fall below 1 in 20,000, we begin to glimpse something even stranger. Maybe the story of 3I Atlas isn't just about its orbit, but about its encounters, the near passes, the gravitational brushes with worlds that seem almost orchestrated. Well, perhaps that's where the next question waits. How did this traveler come so close to so many planets, as if tracing a deliberate tour through our cosmic neighborhood? It drifted past Mars, first a quiet crossing, almost too clean, too perfectly timed. The orbit of 3I Atlas brushed so near that, well, you could almost imagine the red planet pulling at it with invisible fingers. Yet the data showed something stranger. The alignment wasn't just close, it was precise. Within fractions of a degree, the trajectory threaded between the orbits of Mars, Venus, and Jupiter, like a thread guided through the eyes of 3 cosmic needles. That kind of precision, doesn't just happen. It's not random wandering, it's choreography. And Loeb, once, again, paused. Because what we call coincidence in the heavens often turns out to be geometry we haven't understood yet. You see, 3I Atlas didn't simply pass by these planets, it passed near them, within a gravitational whisper's reach, but never quite close enough to be pulled off course. That is what's uncanny. Not just the proximity, but the restraint. It's as if the object was tracing the line between attraction and avoidance, dancing on the edge of planetary influence. The odds of such an alignment are astonishingly low, less than 1 in 20,000, Loeb calculated. If you simulated 1 million interstellar objects entering the solar system with random vectors, almost none would reproduce this exact configuration. It's not just improbable, it's deliberate looking. And that's where the human mind hesitates. Because, the moment something looks deliberate, we start wondering if it is. But Loeb, being Loeb, didn't jump to conclusions. He asked, instead, could these close approaches be the outcome of gravitational refinement? Could the object's earlier encounters, maybe with giant molecular clouds or passing stars, have subtly tuned its path long before it ever reached us? Perhaps, he thought, the solar system itself acts like a filter, guiding objects along certain corridors where the combined pulls of the planets and the sun shape their routes into narrow, elegant lanes. You know, when you look at the orbits of Mars, Venus, and Jupiter together, something remarkable emerges. They form, in a sense, a layered resonance, a rhythm of distances and periods that echoes through the fabric of the solar system. Mars orbits in about 2 Earth years, Venus in less than 1, Jupiter in 12, a ratio that produces gravitational harmonics, gentle tugs repeating over and over through deep time. If an interstellar traveler were to cross this region, it might find itself nudged and steered by those harmonics, like a leaf, drifting through invisible waves. Still, there's something too clean about it, too smooth. The approach to Mars was within a few million kilometers, close enough that its orbit bent slightly, measurable even through the noise of observation. But the next encounters with Venus and Jupiter happened as though predicted by some secret rhythm. Loeb plotted them out, frame by frame, and each passage fell on the exact side of stability, avoiding major deflection while maintaining the same plane. It's not just unusual, it's eerie. That's the thing about 3i Atlas. Every time it could have turned chaotic, it didn't. Every opportunity for randomness passed unclaimed. The probability tree of its motion, all those possible branches narrowed into a single graceful curve. And, when you see that kind of order in nature, you either call it coincidence or you start asking deeper questions about the architecture of the system itself. Imagine this, if you will, a traveler entering a foreign solar system, weaving its way between planets, as though the route were marked out long before. It's not a spacecraft. No, we'd see evidence if it were, but it behaves with a precision that almost feels guided. That is the puzzle. It's not technology, it's tendency. It's the suggestion that space itself can sculpt motion into meaning. So Loeb ran simulations. He tested what would happen if 3i Atlas had entered just 1 degree higher in inclination, or 1% faster in velocity. In most scenarios, the comet would have been drawn off course by Jupiter's vast gravity, thrown into a chaotic slingshot that would eject it far from the ecliptic. But in this precise configuration, it passed by untouched as though, well, the timing was perfect, and that timing extends even further. Each encounter occurred roughly where the planet's gravitational influences balance each other out, the subtle null zones between pulls. It's almost as if the object was surfing the edge of equilibrium, moving where the universe's competing forces cancel into calm. It's an extraordinary thing to see in the numbers, a natural object moving like a mathematician's dream. You might ask, could this simply be the effect of the sun's overall pull dominating all others? Perhaps yes, but that doesn't erase the improbability. Even if gravity is the only hand at play, the precision of these distances defies statistical expectation. Loeb likened it to throwing a pebble across a river and watching it skip perfectly from stone to stone not once, but 3 times, each jump exactly the right length. And this raises another question, one more subtle than it seems. Is space truly empty between the planets? Or do these regions contain faint structures of dust, plasma, or magnetic turbulence that can guide motion like a current? If so, perhaps 3i Atlas is revealing not the hand of design but the fingerprint of the medium itself. The solar system might be more textured than we think. A field of invisible threads, sculpted by centuries of solar wind, planetary magnetism, and the faint drag of interplanetary dust. That idea that the void has texture changes everything. Because it means interstellar travelers don't move through emptiness, but through something akin to water, thin but structured. If the current is right, an object like 3i Atlas could ride it for millions of kilometers, guided subtly but surely toward the paths of least resistance, which, as it turns out, align closely with the orbits of planets. So, well, perhaps that's what happened. Perhaps its path past Mars, Venus, and Jupiter wasn't luck, but consequence, the natural outcome of following these hidden channels. Or perhaps, something else shaped it, something we can't yet quantify, a resonance, a memory in the solar fabric itself. When you step back and look at the big picture, the symmetry becomes breathtaking. Mars, the restless world of rust and dust. Venus, the shrouded mirror. Jupiter, the vast anchor of gravity. 3 very different worlds, 3 gravitational voices, and yet 3i Atlas touch them all, one by one, without falling captive to any. It's almost poetic, a visitor greeting each guardian of the solar system and slipping by unnoticed. Loeb once described it like this: it's as if the solar system held its breath while the object passed. And he's right. The precision of the orbit, the silent threading between giants, the absence of perturbation, it all feels choreographed by something larger than chance. But what if it's not choreography at all? What if what we call order is simply the emergent pattern of billions of interactions we can't yet resolve? It's not that 3i Atlas knows where to go, it's that the universe itself has written subtle lines of least resistance, and the object is just following them. That would be even more profound, because it would mean there's an underlying design to motion, a kind of gravitational language whispering beneath the noise. And that language, might be what connects this object to those that came before, to Oumuamua, to countless unseen travelers crossing the interstellar gulf. Each one an expression of the same cosmic grammar, repeating themes we barely understand: symmetry, balance, improbable precision. Still, the question lingers: why these specific encounters? Why Mars, Venus, and Jupiter, and not Mercury or Saturn? Could the timing have been influenced by its velocity, its orientation, or perhaps by interactions earlier, beyond the heliopause? Loeb speculated about interstellar dust drag, weak but persistent, shaping its course before entry. Others proposed that magnetic fields from passing stars might have imparted a tiny torque, aligning its spin and tilt long before it reached our Sunday. And yet, even with all these possibilities, one fact remains stubborn. The sequence of planetary flybys is too aligned, too orchestrated to be dismissed outright. Each close approach offered us data: small shifts in velocity, variations in light curve, subtle reflections that hint at composition. It's as if the universe, through this object, gave us a moving laboratory, letting us test the laws of motion across planetary scales. But there's another layer, a quieter one. Each encounter, each gravitational near-miss, changes not just the comet, it changes us. Because, well, it forces us to ask whether we've been underestimating the subtlety of our own neighborhood. The solar system might not be the empty space between planets, but a web of interactions, alive with structure and purpose. And as 3I Atlas now drifts beyond Jupiter's orbit, its path beginning to arch outward once more, we find ourselves staring at the data with a mix of disbelief and awe. It didn't just pass through, it navigated. It responded. It taught. And though the encounter may be over, its trail faint, mathematical, persistent remains written across our sky. So perhaps, that's where Loeb's question grows larger. If this object's journey has been shaped so finely by planetary influence, then what about its speed, its mass, its very energy? What hidden forces gave it such momentum, such resilience, and why does it move faster than we'd expect for something so massive? That becomes the next mystery. Because, in tracing its near-perfect path between worlds, we begin to see another puzzle forming in its wake, one not of direction, but of power. How can something so heavy travel so swiftly and still remain so strangely stable? It's not just the road it takes through space that defies our models, but the engine that drives it. And that question, quietly burning beneath the data, leads us forward toward the heart of its impossible speed. It's not just the path that unsettles us, it's the power behind it. You see, when Avi Loeb and his team began comparing 3I Atlas to the other two interstellar visitors we've known, Oumuamua and Borisov, something immediately stood out. It wasn't just heavier, it was faster, much faster. And in the universe, speed is never free. Every kilometer per second carries a price in mass, in energy, in history. So the question becomes, who or what paid that price? The initial calculations? Placed its inbound velocity near 78 kilometers per second relative to the Sunday. That's nearly twice the speed of most long-period comets from the Oort cloud. Twice the speed means 4 times the kinetic energy. And when you consider its estimated mass, larger even than Borisov, which itself was already remarkable, the numbers start to feel, well, excessive. A natural comet should lose speed during its long fall toward the Sun, slowed by gravitational tides and the drag of interstellar dust. But 3I Atlas arrived, with momentum intact, like a stone hurled from somewhere far beyond the Milky Way's quiet edge. And yet, it behaved like a comet, at least on the surface. It glowed, it rotated. It reflected sunlight with the faint variability we associate with uneven surfaces. But that combination, high mass, high speed, stable rotation, doesn't add up easily. It's like watching a boulder skip across a pond without sinking. There's something not just improbable, but almost contradictory about it. Loeb noted that if 3I Atlas were truly composed of light volatile ices, as most comets are, the stress of its acceleration near perihelion would have torn it apart. Ice sublimates rapidly under solar heat, creating gas jets that both propel and destabilize the nucleus. The higher the speed, the greater the fragmentation risk. Yet, it didn't break. Not even a hint of disruption in its light curve. So either the material was far stronger than typical cometary ice, or the acceleration was not driven by sublimation at all. That's what makes it strange. The numbers imply density, perhaps metallic, perhaps composite, something that resists heat and pressure. If that's true, then its mass would be even higher than initial models suggested. And if it's heavier, then the source of its speed becomes even harder to explain. You see, in physics, there's a balance between inertia and impulse. For an object to reach that velocity, something must have pushed it, or it must have been born from a system already moving fast, perhaps a binary star interaction, perhaps an ejection from a collapsing nebula. Loeb explored both ideas, testing whether tidal interactions between stars could fling large fragments into interstellar space at such speeds. It's possible, yes, but rare. Only a tiny fraction of ejected material ever achieves enough escape velocity to travel freely between stars. And of that fraction, fewer still would survive intact, long enough to cross the gulf and enter our solar system. So, again, we return to improbability. High mass, high velocity, stable shape, a combination that breaks the statistical mold. And it's not just about the mechanics, it's about the story those numbers tell. Because every velocity, every acceleration, every deviation from the curve is a piece of autobiography, the memory of forces long past. Imagine, for a moment, the birth of such an object. Perhaps it was once a fragment of a planet shattered by a dying star, or maybe it formed in the dense interior of a protoplanetary disk, deep and metallic, ejected violently when its sun went supernova. That kind of birth could impart the energy we now see, flinging the fragment outward like a bullet through the dark. But if that's true, it means we are observing not just a comet, but a relic, a piece of a world that died before our sun was even born. And, well, that changes the tone of everything. Because what we call speed is really the fossil of a catastrophe. Every kilometer per second it travels is a record of some ancient violence, frozen in motion. That, perhaps, is why 3I Atlas carries a kind of silence about it. Not the stillness of calm, but the stillness of memory. When Loeb plotted its energy profile, he found something curious. The trajectory wasn't purely gravitational. There was, as earlier data hinted, a faint non-gravitational acceleration, consistent, directional, not chaotic. But the key is this. The acceleration vector did not match what we'd expect from solar heating or gas jets. It was too smooth, too constant, and, that suggests either an internal mechanism or a surface reaction we don't yet understand. One possible explanation is asymmetric thermal radiation, sunlight heating one side more than the other, causing a subtle push. But that effect, known from Oumuamua, would require a very high surface reflectivity or a shape optimized for such propulsion. 3I Atlas, by contrast, appears bulkier, less reflective, more like stone than foil, so perhaps we're missing something. Perhaps its speed is not a present effect, but a legacy one, something imparted long ago, and simply preserved. That brings us to its endurance. For an object traveling that fast, interstellar erosion should leave scars. Tiny collisions with dust grains, cosmic ray bombardment, the grinding effects of millions of years adrift, all should roughen its surface, darken it, slow it. And yet, the brightness remains oddly high. It's as if the surface has been renewed, resurfaced, somehow. Maybe through impacts, maybe through sublimation, or perhaps, and this is Loeb's quiet speculation, through melting and refreezing cycles during earlier star passages. Each flyby near a star could heat its crust, smooth it slightly, seal the fractures. A kind of cosmic annealing. You know, when you think of it like that, the comet's speed becomes a metaphor for endurance. It's not just fast, it's ancient, and yet, it's still here, still moving, still coherent. The faster it goes, the longer its story must have been told. And that's what makes this whole case feel almost personal. Because we, too, carry speed. The Earth itself races around the Sun at 30 kilometers per second, our solar system around the galaxy at 220. We are all in motion, forever falling, forever escaping. 3i Atlas just happens to be doing it louder. Loeb once said, in one of his quieter interviews, every interstellar object is a message written in momentum. And maybe that's true. 3i Atlas isn't shouting anything new. It's repeating a word the cosmos has whispered for billions of years. Motion. It's not chaos, it's continuity. Still, the problem remains. The observed non-gravitational acceleration, the same one that suggests a directed push, can't be explained by sublimation unless we assume an enormous loss of mass, over 13% within weeks. That's implausible for a solid object of this density. So, where does that leave us? Either our understanding of outgassing is incomplete, or 3i Atlas is powered by something subtler, perhaps reflective recoil, perhaps electrostatic charge, perhaps, well, something we don't yet have a name for. And this, you see, is where science meets humility, because every time we try to simplify the unknown, it slips through the cracks of our certainty. 3i Atlas may not be rewriting physics, but it is reminding us that physics is never finished. When the team compared its photometric brightness to its velocity curve, they noticed another small irregularity, a phase lag, as though the light variations were not perfectly synchronized with its rotation. That could mean uneven heating, or a layered structure beneath the surface. If true, the mass may not be uniform. It could have a dense core surrounded by lighter material, behaving like a gyroscope as it spins, and, that would explain the stability and also the mysterious retention of speed through perihelion. You can imagine it, a nucleus dense as iron, coated with silicate dust and thin ice, gliding through sunlight like an ancient artifact. Not designed, but sculpted by time, by collisions, by the quiet persistence of motion. Still, there's another mystery in the numbers. If the comet's density is that high, its reflectivity should be low, and yet, it's not. The spectral data show a modest albedo, similar to carbon-rich surfaces. That combination heavy and bright hints at complex composition, possibly metallic inclusions, nickel, iron, carbon. That's not unusual on its own, but in these ratios, it borders on unique. It's almost as though we're looking at the fossilized core of a broken planet, the remnant of something once molten, now drifting in exile. And that thought, that possibility, reframes the question entirely. Because if 3i Atlas began life inside a planet, then its speed, its strength, its resistance all make perfect sense. It's not a comet of ice, it's a shard of a world. And, well, if that's true, then its journey across the solar system isn't just a flyby, it's a reunion of kinds, a fragment of one world brushing past another, separated by light years and time. The more we look, the more human the story feels. It's a reminder that motion, even at cosmic scales, carries memory. That what we see now, this streak of light and speed, may be the echo of a planet's destruction, a final trace of something that once orbited a distant sun. But even that explanation leaves one thing unanswered: the glow. Because 3i Atlas shines with a faint green hue, brighter in specific bands than its temperature should allow. That spectral signature suggests not just mass and velocity, but chemistry, something active, something interacting with sunlight in an unexpected way. And that color, that haunting green, will lead us toward the next question, not of speed or mass, but of light itself. It began with the light. That faint green shimmer that, seemed to cling to the comet's tail like a ghost refusing to let go. At first, no one thought much of it. Comets glow all the time after all. But then came the detail that changed everything. The tail wasn't pointing away from the sun as it should. It was pointing toward it. That shouldn't happen. Every cometary tail we've ever studied, from ancient observations to modern telescopic data, follows a simple rule. Sunlight and solar wind push dust and gas outward, away from the star. It's the one constant amid all the chaos. But 3i Atlas defied that law with quiet confidence. dragging a faint, luminous streak against the direction of solar radiation. Scientists called it an anti-tail. Loeb called it a whisper of direction. And, well, that's exactly what it feels like. A whisper, faint but deliberate, hinting that something deeper is at play. Because, you see, anti-tails aren't unheard of. Occasionally, when the geometry between Earth, the comet, and the Sun aligns just right, perspective can make it look as though a tail points sunward. But the geometry here, simply didn't allow for that. The data from the Minor Planet Center and JPL confirmed that the anti-tail persisted long after the viewing angle had changed. It wasn't an illusion. It was real. So what could cause a comet's material to flow toward the very source of radiation that should be driving it away? Loeb, being careful as ever, proposed several models. One possibility was a jet, a stream of particles ejected from the comet's nucleus in a specific direction, strong enough to overpower the solar wind locally. But that kind of focused jet would require internal pressure and energy that no typical comet nucleus could sustain for so long. The anti-tail stayed visible for days, even as the comet moved away from perihelion. The direction of material flow remained stubbornly aligned toward the Sunday. It's not that the object ignored physics, it's that it seemed to be obeying a version of physics we hadn't yet met. When Loeb plotted the brightness data, the pattern of emission revealed a peculiar rhythm, a cycle of intensification every few hours, as though the source of the jet were rotating in and out of view. That suggests a fixed emission point on the surface, not random sublimation. So, well, either there's a natural vent aligned perfectly toward the Sun, or the object itself has some internal structure capable of sustaining a steady, directional release. That's where things get even stranger, because you see, 3I Atlas doesn't fit the profile of an icy body. Its spectra show only trace water vapor, maybe 4% of what we'd expect from a comet of its size. There's not enough ice to generate such consistent ejection. So, what's left? Dust, metal, carbon compounds, materials that shouldn't sublimate easily under solar heat. Which means whatever is driving this anti-tail is not evaporation, but something else. Perhaps reflection sunlight, scattering off fine dust grains, arranged in a very specific way. But again, that geometry doesn't hold for so long, unless the dust itself is being directed. And that's the key word, isn't it? Directed. Loeb once remarked, almost softly, that the anti-tail is less a feature than a gesture. A gesture, he said, because it points back toward the source, as though the object were in conversation with the Sunday. That's the kind of language he uses, poetic, yes, but grounded in data. The idea isn't that 3I Atlas chooses its orientation, but that something within its internal structure favors that configuration. It's as if the nucleus remembers where the Sun is and reorients its emissions accordingly. You can picture it, a dark, compact body rotating slowly, releasing fine streams of dust from a narrow vent or crevice, each stream curling under the influence of rotation, until together they form a sunward-pointing veil. The effect would appear continuous from our vantage point, a luminous ribbon defying intuition. That, at least, is one natural explanation. But even then, there's a problem. The measured acceleration due to this supposed jet doesn't align perfectly with the anti-tail's direction. It's offset slightly, but enough to suggest that the two phenomena may not share a single cause. So, maybe we're seeing two layers of activity. One visible, the anti-tail, and one invisible, an internal or magnetic process, driving motion in a separate axis. If that's true, it could mean that 3I Atlas interacts with the solar environment in a way other comets don't. Perhaps the object carries its own magnetic field, faint but organized, capable of channeling charged particles along specific lines. That would explain the persistence of the sunward flow, as well as the consistency in its spectral color. Still, well, that's a bold claim. A magnetized comet nucleus would be unlike anything we've confirmed before. But Loeb's analysis doesn't rule it out. And if there's one thing 2025 has taught us, it's that the universe seems less concerned with our comfort zones than with our curiosity. The anti-tail, in this light, becomes more than an anomaly. It becomes a signature. It's not just a comet trailing light, it's a system, a dynamic interplay between solid matter, sunlight, and possibly electromagnetic structure. When you imagine it that way, you realize this is not defiance of physics, but expansion of it. Now, consider this. As the comet moved outward after perihelion, the anti-tail did not fade uniformly. Instead, it brightened briefly before vanishing. That, implies a second burst of material, perhaps triggered by internal heat redistributing through the nucleus. But the direction remained the same. That kind of consistency is almost eerie. It's as if the comet remembers where the sun was, even as it drifts away. Some astronomers suggested the effect might come from larger, heavier dust grains lingering in the comet's orbital plane, forming a flat sheet that, from Earth's perspective, seems to extend toward the Sunday. That model fits the light curves, but not the persistence or periodic brightening. The geometry would change too quickly. The anti-tail, instead, seemed to possess its own timing, its own heartbeat. Loeb compared the data to simulations of radiative particle dynamics and found an intriguing possibility. If the dust grains were coated in reflective minerals or metallic compounds, say, nickel or iron oxides, their interaction with sunlight could generate localized heating, leading to controlled re-radiation of energy. Essentially, the dust could glow back toward the Sunday, and if the nucleus were emitting such material in a rotating jet, the apparent anti-tail would trace that luminous feedback. It's beautiful, isn't it? A body traveling between stars, breathing light back toward the one star it briefly meets as if saying goodbye in the only language it knows. But beneath that poetry, lies something deeply technical. Because if this model holds, it means 3I Atlas isn't just reflecting sunlight, it's converting it, interacting with it in ways that suggest complex surface chemistry. That could hint at a mixed composition of conductive and insulating materials, capable of storing and redistributing heat. And that opens an entirely new conversation about how interstellar objects age, how they gather cosmic dust, radiation scars, and magnetic memory over millions of years. Perhaps that's why the anti-tail is so captivating. It's not just light, it's history made visible. It tells us that 3. Atlas has been through enough journeys, enough suns, to know how to glow in defiance of the expected. Loeb often reminds his students that nature doesn't break laws, it reveals larger ones. And maybe that's what we're witnessing here, a glimpse of a mechanism that bridges the familiar and the foreign. Because, when we look at this anti-tail, what we're really seeing is motion sculpted by memory, and it's hard not to feel, a sense of intimacy in that idea. The comet, for all its alien origin, responds to sunlight, the way living things respond to warmth, not just retreating, but reacting. The anti-tail becomes a quiet metaphor for attention, for connection across impossible distance. Still, data demands rigor. The next step is to model how the orientation of the anti-tail evolved with time, comparing it to the comet's rotation and orbital progression. If the alignment holds across those frames, it may confirm that this wasn't a simple geometric illusion. It was an active process. And that leads to the next, even subtler puzzle. Because if light and dust can be directed so precisely, then the structure of the nucleus must allow for channels or patterns of emission we've never seen before. It's not smooth, it's sculpted. And if it's sculpted, it carries a map of internal asymmetry, one that might explain not only its anti-tail, but also the strange chemical ratios in its core. The light may be pointing us, quite literally, toward the materials that built it, and those materials, as Loeb suspected, might not be entirely ordinary. The light, strange as it was, told only half the story. The other half came from silence from what wasn't there. You see, when scientists analyzed the composition of 3I Atlas after its closest approach to the Sun, they expected to see something familiar, something comforting, the unmistakable spectral signature of water, but it wasn't there. Or rather, it was there in whispers faint, thin, almost apologetic, only about 4% of the expected value. That number, well, it hit like a quiet shock across every observatory that followed the data. Because for a comet of its size, water should not just exist, it should dominate. That's the first thing Loeb pointed out. If this object were born in a typical planetary nursery, he wrote, it should be dripping with ice. And yet, when the spectral lines came through, the familiar OH bands, the markers of vaporized water, were barely visible. It's as though the comet had shed its most basic signature, as if the very thing that made it a comet had been burned away long ago. And that absence, it changes everything. Because in our models, comets are time capsules. They are the frozen leftovers from a star's infancy, holding within them the record of what was the primordial mix of ice, dust, and organic molecules that predate planets themselves. To find one that's nearly dry, nearly stripped of water, suggests either immense age or an origin radically different from any system we know. But that's not the only clue. The small amount of water that was detected seemed oddly bound, trapped in minerals rather than free as ice. In spectroscopy, those signatures appear as faint, broadened features, almost swallowed by the continuum. It implies that what little hydrogen and oxygen remain are locked within rock, fused under heat and pressure. And if that's the case, 3I Atlas isn't a frozen traveler at all. It's something tougher, denser, forged in a furnace rather than in frost. So, Loeb began to wonder, what if this object is not a comet, but something more like an asteroid, disguised as one, a rocky interstellar relic, covered in dust and oxidized minerals, carrying only the faint memory of ice within its pores? The numbers point that way. Its density, its reflectivity, its resistance to outgassing all lean toward the rocky side. But the green glow, the anti-tail, the weak vapor emission, those still whisper, comet. It's both, and it's neither. It's not a contradiction, it's a hybrid. And, that hybrid nature is what fascinates Loeb, because it tells a story of transformation. Imagine a body born in the outer regions of a foreign star system, cold, stable, covered in ice. Over billions of years, it drifts through space, passing near stars, absorbing radiation, losing water molecule by molecule. Each close encounter burns away a little more of its original self, until what remains is a skeleton of stone and carbon, bleached by starlight. By the time it reaches us, the water is gone, the structure hardened, the chemistry alien. It's not a messenger from another world, it's the remains of one. There's something poetic about that. We often think of comets as symbols of beginnings of creation, of the water that seeded planets like ours. But here, 3I Atlas represents the opposite. Not birth, but endurance. It's what happens when time outlasts everything soft, when even the simplest molecule water gives way to something unyielding. And, this discovery forces us to rethink our assumptions, because if interstellar comets can exist without water, then water is not the universal signature of life's building blocks we once thought it was. Maybe, in other corners of the galaxy, worlds form and evolve from materials we barely recognize, dry, metallic, carbon-rich. Maybe the ingredients of life don't need water at all, or maybe they begin in its absence. Loeb often says that absence can be as revealing as presence, and the absence of water here is deafening. It tells us about entropy, about the slow evaporation of identity across cosmic time. Every pass near a star strips a little more away. Every journey through interstellar dust scours the surface, seals the cracks, and hides the history. So when we finally meet such a packed traveler, it arrives as a fossil, a survivor of countless transformations. But, there's more. Because the lack of water doesn't just reshape the story chemically, it reshapes it physically. Ice, when it sublimates, drives the jets that sculpt a comet's tail. Without it, those forces vanish. And yet, 3I Atlas moves as though it has them. The directed acceleration, the anti-tail, the faint emissions, they all mimic the behavior of water-driven activity without the water itself. It's imitation without source, a performance without an actor. So, how is that possible? Loeb suggested that other volatile compounds might be taking water's place. Carbon monoxide, carbon dioxide, even metal-rich dust that reacts to sunlight differently. These materials can sublimate or ionize at higher temperatures, producing visible emissions without requiring ice. It's an elegant possibility, one that turns our model of cometary chemistry upside down. Perhaps the universe has More than one recipe for the same spectacle. That idea, that flexibility, is humbling. It reminds us that what we see from Earth, a glowing tail, a passing light, may come from entirely different origins than we assume. It's not that our physics is wrong, it's that our sample size has been small. Every new interstellar object adds a verse to the poem we're still trying to finish. When the spectrometers at JPL and ESO combined their data, they found faint traces of hydroxyl radicals and, surprisingly, silicate vapor, the kind produced when rock, not ice, begins to release its minerals under extreme heat. That discovery stunned the observers, because, silicate vaporization requires temperatures far above those found near Earth's orbit. It implies that parts of 3I Atlas's surface reach several hundred degrees Celsius during perihelion hot enough to melt glass. And, that's not what comets do. They fragment, they crumble, they fade. But 3I, Atlas endured. The heat didn't destroy it, it revealed it, which means its nucleus must be stronger, denser, more cohesive than any ice rock blend we've catalogued. It's a survivor not of cold, but of fire. So perhaps what we're seeing is a new class of object altogether, a dry, rocky body that masquerades as a comet because it still carries traces of the processes comets exhibit, a mimic, not an imposter. And that subtle difference, that ability of nature to echo familiar behavior through different means, is what fascinates Loeb most. It's not deception, it's diversity. You can almost imagine, the interior of 3I Atlas as a mosaic of materials, fragments of silicates, veins of metal, cavities lined with carbon-rich compounds. Water once filled those gaps, long ago, but now only the ghosts of those molecules remain, their absence creating channels that guide light and heat in strange, uneven ways. Perhaps that's why the emissions are so asymmetrical. The comet doesn't just reflect sunlight, it channels it, through a body that's hollowed by time. That image, that sense of a hollow traveller, carries something quietly human in it. Because we, too, are shaped by what's missing. The gaps between our certainties define the space where wonder lives. 3I Atlas, in that sense, is a mirror not of water and dust, but of curiosity itself. Still, Loeb pressed further. If there's so little water, what binds the dust together? What gives the nucleus its coherence? The answer, perhaps, lies in chemistry we don't fully understand, metal oxides, carbon networks, nickel-rich inclusions. These materials can sinter together under heat, forming a structure that resists fracturing even when spinning or accelerating. That could explain why 3I Atlas hasn't broken apart, why it shines and moves as though built for endurance, and, well, it leads to another thought. If the nucleus is that strong, that metallic, then the spectral anomalies in its glow might not just come from dust, they might come from the metals themselves. Nickel, iron, cobalt, all can emit faint green and blue wavelengths when ionized by sunlight. That could mean that the beautiful hue we see, the one that makes 3I Atlas so distinctive, isn't just a play of light, it's chemistry revealing itself in motion. Which brings us to a fascinating crossroads, the place where composition meets color, because in science, color is never only beauty, it's a code, a fingerprint, and the strange green of 3I Atlas, persistent and bright, may carry within it the signature of elements no comet should possess in such abundance. And that, as Loeb hinted in his final notes on the data, is the next puzzle waiting to unfold a question not of structure or water, but of what metals could glow so vividly in the vacuum between stars. It was the color that betrayed it first, that strange green gleam that shimmered just beneath the dust, as if the object were breathing light rather than reflecting it. You see, when the spectrometers caught those wavelengths, they revealed something no one quite expected. The emission wasn't dominated by water, or by the faint carbon compounds typical of comets. It was metal, nickel, specifically. And not just a trace amount, it was abundant, disproportionately so. That shouldn't happen. In every comet we've studied across our solar system, from the cold fragments of the Kuiper belt to the ancient visitors from the Oort cloud, iron always outweighs nickel. It's one of the most stable cosmic ratios, a fingerprint of stellar nucleosynthesis. The cores of stars produce more iron than nickel by far, and so, naturally, every planet, asteroid, and comet born from stellar dust reflects that bias. But in 3I Atlas, the ratio was inverted. Nickel surpassed iron by a margin too wide to ignore. Loeb, sat with that number for a long while, because numbers like that don't just describe their cues. They suggest that the object didn't form in the kind of environment we know, that it was forged under conditions hotter, denser, and more selective than nature usually permits for something drifting through interstellar space. Well, the possibilities are unsettling. To have such an overabundance of nickel, you need processes that separate metals by volatility or density, something that smelts, that refines. In other words, conditions that mimic industrial metallurgy. Of course, no one is saying 3I Atlas is a machine, but the chemistry whispers of precision, of selection, and, that's the kind of whisper scientists can't ignore. When sunlight hit its surface, the spectral lines of nickel ionized, glowing faintly in the visible range, contributing to that ghostly green hue. And that's the thing, green light from nickel is not something you see in nature's cold comets. It requires heat, energy, interaction. It's the color of a metal remembering the forge that birthed it. Loeb compared the data to meteorite samples and known cometary spectra. None matched. Even the metallic meteorites from our solar system, formed from planetary cores, carry nickel in smaller fractions, around 10% of iron content. But in 3I Atlas, that ratio flips. It's more than unusual, it's systemic. The whole structure, from the dust in its tail to the solid fragments ejected from its surface, seems built from the same alloy. And so, we're forced to consider origins that lie beyond the ordinary. Maybe this object came from a region near a dying star, where heat and radiation stripped lighter elements and left only refractory metals. Or maybe it was once part of a larger body, the core of a world shattered by catastrophic impact. Its outer layers gone, its heart exposed, it drifts now between suns, carrying the memory of fire in its skin. That, in a sense, feels almost tragic, because if that's true, then 3I Atlas isn't just metal-rich, it's the grave of a planet, a survivor of destruction so vast we can barely imagine it. Loeb phrased it differently, though. He said, this could be an interstellar remnant of planetary engineering, not meaning by hands, but by nature herself, the greatest engineer of all. When a planet dies, when its crust melts and its metals separate, the laws of thermodynamics do their work. Heavy elements sink inward, light ones escape. If the body is torn apart, fragments of that metallic core can be cast into the galaxy, refined by cosmic violence, into something like what we now see. And, that image of destruction, creating purity, haunts the data. The green light of 3I Atlas isn't just the signature of nickel, it's the echo of catastrophe. It's what happens when creation and ruin meet halfway. Still, there's another possibility, and Loeb, being careful, never dismissed it. What if the nickel isn't native? What if it's accreted, gathered over time from interstellar dust and plasma? There are regions in space where magnetic fields trap charged particles, allowing metals to coat the surfaces of travelers like this one. Over millions of years, a thin film of nickel could build up, altering both its reflectivity and emission lines, but that theory struggles with the depth of the signal. The abundance in the tail indicates that nickel isn't just on the surface, it's in the core. So, well, if it's truly intrinsic, then 3I Atlas is telling us that not all planetary systems follow our recipe. Somewhere out there, perhaps around another kind of star, one with a different metallicity, a different fusion history, there are worlds where nickel is more common than iron. Worlds with surfaces that shine pale silver instead of red, where dust carries different colors, where chemistry itself writes another chapter of possibility. And that's the astonishing part. This single object, this one, the shard of another sun's story, might already be rewriting our understanding of how matter distributes itself in the universe. It's not just about 3I Atlas, it's about everything that could exist beyond the boundary of our expectations. When Loeb's team examined the emission ratios in the tail more closely, they noticed something even more peculiar. The nickel line intensity wasn't constant. It pulsed, faintly but rhythmically. As the comet rotated, the signal brightened and dimmed with remarkable consistency, suggesting that certain regions on its surface were richer in metallic compounds than others. That kind of surface variation implies structure layers, veins, differentiation. You can almost imagine it, the comet spinning slowly through sunlight, one side revealing a field of reflective nickel crystals, the other side darker, rougher, more carbonized. As it turns, it glints a rhythmic flash, a cosmic heartbeat of metal and dust. And that, opens a new question, because nickel, unlike ice, conducts heat. It can store energy and radiate it differently depending on its orientation. That could explain not only the peculiar light variations, but also the measured non-gravitational acceleration. A metallic surface could re-emit absorbed solar energy as thermal radiation, creating a steady push, a self-balancing propulsion effect. It's not intention, it's physics, but it behaves with eerie precision. Loeb considered that model, noting how similar it sounded to the hypothesis proposed for Oumuamua, that light itself might push it through space. But here, the composition makes the case stronger. A metal-rich body could indeed harness radiation pressure more effectively, explaining the subtle, directional acceleration without invoking outgassing or sublimation. It's a simple explanation hiding behind complex beauty. And yet, simplicity doesn't make it less mysterious. Because if radiation pressure alone accounts for the motion, then 3I Atlas must be remarkably smooth in some regions, almost polished. And that's not what we see in comets. That's what we see in engineered alloys, in surfaces shaped by heat and pressure into coherence. So maybe that's it. Maybe nature is the great engineer after all, and this object is her masterpiece, a fragment so ancient and refined that it reminds us how creation itself is an act of trial by fire. Loeb once described the spectrum of 3I Atlas as a song played on unfamiliar strings. Each metallic note reveals a part of its story, but the melody feels otherworldly. The dominance of nickel, the balance of iron, the faint traces of cobalt and chromium, together they paint a portrait of an object too hot to be a comet, too volatile to be a mere asteroid. It sits in between, defying our categories, asking us to widen our definitions. And that's, well, the most humbling part of all this, because science, at its core, isn't about certainty. It's about accommodation. Each anomaly asks us to make room for a larger truth. And this one, this shining, silent traveler, asks for a room big enough to hold the idea that the universe might be building with materials we've never seen before. Still, one puzzle remains unresolved. Nickel explains the glow, the metallic stability, even the acceleration, but not the color entirely. There's something else mixed into that green light, something molecular, something reactive. Loeb mentioned faint traces of carbon monoxide ions Co+ in the emission data. Their presence hints at another layer of activity, another spectrum waiting to be untangled. So, perhaps, what we're seeing isn't just metal, but chemistry, the dance between metal and gas, between reflection and reaction. The next step, naturally, is to follow that color where it leads, into the heart of the light itself, where composition becomes motion, and motion becomes meaning. It's strange, isn't it, how light can carry a secret? You see, when scientists first turned their spectrographs toward 3I Atlas, they didn't just see brightness, they saw color. That brilliant, living green, more intense than any ordinary comet should ever produce. It shimmered through the void like something alive, flickering slightly as the object spun, pulsing softly with each rotation. And that color, that hue, was more than beauty, it was evidence. Every wavelength tells a story. The green in question wasn't just the soft fluorescence of carbon compounds reflecting sunlight. No, it was sharp, spectral, anchored around 460 nanometers, the signature band of ionized carbon monoxide, CO+. And that is where things began to twist, because CO+ emission requires a level of energy that ordinary cometary activity can't easily sustain. To ionize carbon monoxide, you need both ultraviolet light and a persistent source of heat, either internal or environmental. Loeb looked at that data and frowned, or rather, he smiled, the way scientists smile when nature teases them. Because, it meant that 3I Atlas wasn't just reflecting sunlight. It was interacting with it. Its surface and gases were transforming that radiation, turning it into fluorescence, glowing from within. That, in itself, isn't entirely unheard of. Some comets, especially those near Perihelion, show faint CO+ lines, but here, the brightness was beyond anything comparable. It was as if the entire tail had become a slow-moving plasma. So, well, there were two paths of thought. Either the glow was a product of natural sublimation, some exotic chemistry triggered as the object neared the sun, or, perhaps, the heat wasn't entirely from the sun at all. Perhaps it came from within. The first theory, the natural one, is elegant. In it, the CO+ forms as residual carbon compounds trapped in the comet's crust escape under solar heating. As ultraviolet photons strike them, electrons are stripped away, producing that green emission. The same process happens in auroras on Earth, the dance of charged particles meeting atmosphere. But the second theory, the one Loeb hesitated to write but couldn't quite ignore, was different. It suggested that something internal, thermal, mechanical, maybe even magnetic, was feeding the process, creating localized heating far beyond what sunlight alone could do. That's the thing. The temperatures required for such intense ionization exceed the expected surface temperature of the comet by several hundred degrees. That kind of sustained glow means either a constant replenishment of particles or a heat source capable of keeping them excited long after they should cool. It's like watching embers that never go dark. And here's where it gets curious, because when Loeb mapped the brightness variations over time, he found a regular pattern, not random flickers, not chaotic bursts. The glow followed the comet's rotation, brightening and fading as though fixed to certain longitudes. That means the emission isn't global, it's localized, tied to specific regions. So, well, something on the surface is acting like a repeating beacon, lighting up in rhythm with the spin. If it were purely natural sublimation, we'd expect irregularity gas jets, turbulence, randomness. But this was structured, not artificial, necessarily, but ordered. It's not that it breaks the rules, it suggests there are rules we don't yet know. Now, about the intensity. The green band from 3I Atlas was nearly 5 times stronger than what's typical for a comet at its distance from the Sunday. That means an incredible amount of CO or CO-bearing compounds must be exposed, and not just exposed but energized. And, that energy has to come from somewhere. One possibility is that the surface contains catalytic minerals, nickel and iron again, that help to retain and redistribute heat. If sunlight strikes these materials, they can radiate energy unevenly, creating small pockets of warmth that ionize surrounding gas. It's chemistry behaving like engineering. And, well, there's a poetic symmetry to that, isn't there? The same metals that once might have formed the heart of a planet now act as mirrors, amplifying light across the vacuum. The glow becomes a memory not of birth, but of endurance. Loeb often says that color is the first language of the universe. And in that sense, this green light is a kind of sentence, a statement written in energy. It says, I am still reacting. I am still alive in the physics that made me. But of course, scientists aren't content with poetry alone. They looked for data for numbers that could anchor wonder. The ionization ratio, for instance, suggested that CO+ wasn't alone. Fainter traces of CN cyanogen were there too, weaving secondary bands through the spectrum. Normally, that's the fingerprint of a young, icy comet, full of volatile compounds boiling off its surface. But here, without water ice, without the usual emissions of OH or H2O, the cyanogen becomes anomalous. It's being produced by something other than standard sublimation, perhaps by recombination reactions between carbon monoxide and nitrogen trapped in the mineral matrix. In other words, 3I Atlas might be performing chemistry in real-time, chemistry we've never seen outside of a lab, the kind that happens when matter forged under alien conditions meets sunlight for the first time in eons. So, Maybe this color isn't accidental. Maybe it's the fingerprint of an origin we don't yet have a category for. The ratio of CO plus to CN, the intensity curve, the green's persistence, they all point to a process that's steady, not explosive, controlled even. That steadiness, that discipline of emission, is what makes this so haunting. Most comets are chaos-made visible jets, flares, fragmentation. 3I Atlas, instead, glows with composure. The light isn't desperate, it's deliberate. It's not screaming, it's humming. And that hum, well, it's a clue. When Loeb modeled the internal heat distribution needed to sustain such fluorescence, the results were startling. The nucleus would have to hold residual thermal gradients, possibly from its interstellar journey, stored heat trapped in metallic veins, slowly released over time. If those metals have high conductivity, they could carry solar energy inward, where it warms gas reservoirs, re-emitting light long after direct exposure fades. That could explain the consistency. It's not that the comet burns, it breathes. And that breathing, that slow exchange of heat and light, could persist for weeks or months, far longer than typical cometary activity. In that sense, 3I Atlas becomes less a visitor and more a phenomenon, an object that remembers how to glow, as if life itself were a property of matter under certain conditions. There's something almost biological about it. Cycles, rhythms, responses. Loeb, of course, stops short of that comparison. But he notes, quietly, that systems capable of maintaining non-equilibrium states, that is, states that keep reacting long after the stimulus changes, are rare in nature, but not unique. Stars do it. Planets do it. And, maybe, under the right conditions, interstellar relics do it too. The deeper mystery, though, lies in the color's persistence even after perihelion. Normally, once a comet passes its closest point to the Sun, its activity fades. But for 3I Atlas, the opposite happened. The green intensified after perihelion, as though the heat stored within was now emerging from beneath the surface, carried outward. It's like the object took in light and was now giving it back, but in a different tone, a slower rhythm, a reply delayed by millions of years of travel. You can almost imagine it glowing faintly in the blackness, long after it should have gone dark, a reminder that in the universe, nothing truly stops it, just changes form. And, well, that idea, that light as dialogue, is powerful, because every color is an answer to a question we might not have asked yet. Why green? Why so strong? Why now? Maybe the answer lies not in the light itself, but in the chemistry that enables it, a chemistry that defies the comet's icy classification. So, perhaps, we're looking at something transitional, a bridge between the metallic and the molecular, between the solid and the gaseous. And that bridge, that fragile boundary, where matter begins to speak in photons, is where the next set of mysteries awaits. Because if the light tells us what the comet's surface is made of, the heat behind it might tell us how it moves, how forces we can barely see can drive something so large, so alien, across the solar system, with such quiet precision. It always comes back to motion, not the kind we see, but the kind we can't. You see, when R.V. Loeb looked at the new post-perihelion data in late October and early November, what he found was subtle, almost hidden beneath the noise. The trajectory of 3I Atlas was shifting, ever so slightly, in a way that gravity alone could not explain. That's what they call non-gravitational acceleration, a small, persistent push that acts on an object even after it's left the Sun's immediate influence. And, well, that push was measurable. 1.1 times 10 to the power of -6 inches. The radial direction, 3.7 times 10 to the power of -7 inches the transverse. Not huge, barely a breath compared to the Sun's gravitational pull, but statistically undeniable. Around 3.7 sigma, which means the signal wasn't noise. It was real. It was happening. Now, for comets, that kind of residual acceleration isn't unheard of. Usually, it comes from jets, gas vents, that erupt as ice sublimates, pushing the nucleus in the opposite direction. Like tiny thrusters, natural and chaotic. But, here's the thing. There were no jets, no gas plume, no outgassing halo at all. After perihelion, When the comet should have been at its most active, the space around it remained eerily clean. So that's the contradiction: the object is accelerating as if something is pushing it, yet nothing visible is doing the pushing, and that's what unsettled Loeb. Because if the source isn't sublimation, then what is it? He looked closely at the orientation of the acceleration vector, the direction in which this extra motion pointed. It lined up neatly with the comet's radial path, away from the sun, but lacked the perpendicular component you'd expect from uneven jets or tumbling behavior. It was smooth, steady, aligned. That's not random, that's guided. So, perhaps it's radiation pressure, the gentle push of sunlight on the comet's surface. But again, that explanation only works if the object's mass-to-area ratio is incredibly small, like a thin sheet rather than a solid rock. 3I Atlas is anything but thin. Its inferred density and brightness suggest a compact, heavy nucleus. Radiation pressure would be negligible against that weight. And yet the data says otherwise. Well, that's the thing about physics. It doesn't lie, it only humbles. Loeb proposed that if the acceleration was real, and the lack of debris confirmed it, then the surface of the comet must be doing something extraordinary with light. Maybe, he thought, the metallic composition is the key. Nickel and iron, if arranged in fine, reflective grains, could create asymmetric heating across the body. That heating, in turn, could radiate energy unevenly, a thermal recoil, like a slow exhale of light itself. This idea isn't new. It's an extension of what was suggested for Oumuamua years ago. But here, it's clearer. The green hue, the metallic composition, the steady, post-perihelion, brightening, they all fit into a picture of an object being subtly propelled, not by gas, but by light. Imagine it a body so finely balanced, so sensitive to solar energy, that each photon becomes a push, each glint a breath. It's not a sail, not in any engineered sense, but it behaves like one. A natural mirror sculpted by eons of exposure, responding to sunlight as though it remembers how. And, that's what makes 3I Atlas both beautiful and baffling. Because if the effect truly comes from reflected or re-emitted light, it means we're witnessing one of the most delicate interactions in the cosmos: energy turned into motion by nothing more than surface texture. No engines, no jets, just geometry and patience. Still, Loeb knew the stakes. If the acceleration were natural, then our models of cometary physics need updating. If it weren't, well, the implications grow stranger. Because this push, steady, radial, quiet, resembles something directional, something consistent across time. It's not chaotic like sublimation. It's symmetrical, deliberate, almost designed. But, before imagination runs too far, he grounded the question in observation. To sustain such a force without visible outgassing, the comet would need to lose around 13% of its mass over a month. An enormous number. That much material would form a visible coma, a bright, vaporous shell, yet nothing like that appeared in any post-perihelion image. The comet remained sharp, clean, unshrouded. So perhaps, well, it's not losing mass at all. Perhaps the motion isn't a reaction to ejection, but to reflection, a slow transfer of momentum from sunlight to surface. If that's true, then 3I Atlas might represent an entirely new class of interstellar object, one dominated by radiation physics, rather than by outgassing thermodynamics. Loeb's analysis of the acceleration direction supports that. There's no significant normal component, no sideways push, only radial. That's what makes it so strange. It behaves like a light sail without being one. The simplest explanation, sublimation, doesn't work. The most natural one, radiation pressure, seems too weak, and so we stand at a crossroads between models, watching the data bend our understanding. And, that's science at its best, isn't it? The universe hands us a number, and we must decide whether to adjust our equations or our imagination. When you think about it, non-gravitational acceleration is more than just motion, it's resistance too. It's an object refusing to follow the strict path gravity writes for it. It's an act of deviation, small but profound. And in that sense, 3I Atlas is like a whisper in the laws of motion saying softly, "I don't move the way you think I should." That whisper now echoes in every dataset from JPL to ESO. The acceleration persists, even as the comet moves, farther from the sunday. Normally, such forces fade rapidly as solar energy weakens, but here, the decline is slower, more graceful. As if the comet stores the light, releasing it gradually. That idea of light being trapped and re-emitted fits beautifully with the metallic composition we've already seen. Metals can absorb radiation deeply and release it over time, creating sustained recoil. If that's true, then the comet isn't just reacting to the sun, it's remembering it. Its motion becomes the shadow of earlier illumination, a delayed conversation between heat and trajectory. That's not mechanics alone, that's memory written in physics. And Loeb, he sees that as an invitation. Because every time the universe offers a paradox, it's really offering a map a way forward, a new law waiting to be discovered. Maybe the equations we use to describe sublimation-driven acceleration are too narrow. Maybe, in a universe of infinite textures, there are other ways for light to move matter. So, we begin to see this non-gravitational motion not as an error, but as evidence. Evidence that our models of how objects travel between stars, of how surfaces interact with radiation need to grow. 3I Atlas, then, is not an exception, it's a teacher. It's showing us that even the smallest acceleration, measured in the quietest decimals, can reveal an entire chapter of unseen physics. And well, that realization leads us inevitably to the next puzzle. Because if the comet truly isn't losing mass, and if light alone can explain its push, then something else must still account for its missing signature, the invisible plume. The silent halo that physics insists should be there, but isn't. And that absence, that hollow where vapor should glow, will become the next question, the mystery of the missing. 13%. It's the absence that lingers longest, isn't it? You see, when Loeb ran his final simulations after Perihelion, he expected the comet's supposed mass loss, the missing 13%, to manifest as a faint, measurable cloud of vapor and dust. But it never appeared. Not in the optical, not in infrared, not in ultraviolet. The space around 3I Atlas stayed quiet, clean, indifferent. There should have been a plume, a halo, a spectral fingerprint of release. There was nothing. Just motion without debris, acceleration without exhaust. And, that emptiness isn't merely lack, it's information. It tells us something about what didn't happen. Because for a comet to accelerate that strongly through sublimation, it must shed enormous mass. The result would normally be obvious. A tail widening in the wake, light scattering across millions of kilometers. But 3I Atlas traveled like a ghost, unburdened, unbroken, as though its acceleration had no cost. That is where Loeb began to rethink everything. Maybe, he thought, the missing 13% isn't missing at all. Maybe it was never ejected. Maybe it was transformed. The numbers, suggest a possibility, both subtle and strange. If the surface of 3I Atlas contains metal oxides, or layered conductive grains, sunlight could penetrate and heat these materials internally. Instead of evaporating mass into space, the object could convert that energy into radiation, emitting it as momentum-carrying photons. In essence, it wouldn't be losing mass but trading it, converting heat into motion directly, not burning, but shining its way forward. That's a poetic idea, but also a physical one, because in relativity, light carries momentum. Every photon that leaves a surface imparts a tiny recoil. On Earth, we call it negligible. But out there, where friction vanishes and gravity softens, those tiny pushes add up. A mirror reflecting sunlight experiences a measurable force, small yet continuous. Over time, it moves. So maybe, 3I Atlas isn't hiding its tail. Maybe its tail isn't made of matter at all. Maybe it's made of light. You could think of it like this: a comet shedding brightness instead of dust. It's not losing pieces of itself, it's radiating them in energy form. That would explain the clean silhouette, the unbroken shape, and the persistence of acceleration long after perihelion. The missing mass, in that case, was never expelled as vapor. It was liberated as photons. Loeb ran the math again, reluctantly, carefully. The energy required to produce the observed acceleration matched almost exactly what would be expected if a small fraction of the incident, solar energy, were being reflected or re-emitted directionally. Not much less than 1% of the sunlight hitting its surface, but enough to account for the motion. And, that's where the mystery starts to sound less impossible and more inevitable. Because if the comet's acceleration can be powered by light alone, then it blurs the line between passive reflection and active response. The object behaves as though it's using sunlight efficiently, as though its surface is tuned to it. Whether that tuning is coincidence or consequence, well, that's the question. Loeb liked to remind his students that coincidence is just ignorance wearing a clever disguise. Perhaps the metal-rich crust of 3I Atlas evolved over time, its surface sintered smooth by countless star flybys, each one polishing it further until the geometry favored radiation recoil. A natural sail, shaped by no hand yet functioning with purpose. Not designed but sculpted by survival. And, well, that's what makes it extraordinary. Because when we look at 3I Atlas now, we're seeing something that shouldn't be able to move like this, doing exactly that, not by burning, not by shedding, but by shining. It's like watching a planet learn to move by remembering light. Still, there's something eerie in the perfection of it. Every model of sublimation or fragmentation fails to match the data. Every explanation that invokes jets collapses under the weight of its own assumptions. Only the radiation model survives, slender and elegant, like a bridge across the unknown. But then comes the question that Loeb himself couldn't quite silence. If this object is a naturally polished fragment, how many others like it must exist? How many interstellar bodies wander the void, reflecting sunlight with such precision that they drift across galaxies, carried not by gravity but by starlight itself? You see, in that question lies something deeper, because the missing tail isn't just a physical puzzle, it's a metaphorical one. The universe seems to say, again and again, that motion doesn't require destruction, that maybe endurance can be its own form of propulsion. Perhaps this object has survived for eons because it learned how to use energy rather than resist it. It's not just a body pushed by light, it's a survivor guided by it, not defying entropy, but dancing with it. When Loeb compared the trajectory curve to earlier interstellar objects, something remarkable appeared. The pattern of deviation, that slow, elegant drift away from the expected path, was almost identical to that seen in Oumuamua 8 years earlier. The magnitude differed, the material differed, but the shape of the curve, the smooth, radial symmetry was the same. It's as though both objects were playing by the same hidden rule. So perhaps, they are not anomalies, but examples of a category we've only begun to glimpse, interstellar relics, shaped by light, evolving not through collision, but through radiation. Imagine a galaxy where billions of such objects wander, silent and gleaming, moving between systems on trajectories written not by mass but by reflectivity, a slow, luminous diaspora of metal and dust. That's what the missing plume might really mean. Not loss, but transformation, the proof that matter and energy, once again, are not opposites but partners. And when you think about it that way, well, it's humbling. Because 3I Atlas isn't breaking the laws of physics, it's obeying them more completely than we ever have. It's showing us that sunlight itself can be a kind of memory, that radiation pressure isn't a footnote in celestial mechanics, but a force capable of steering worlds. Perhaps the missing 13% was never meant to be seen. Perhaps it was never matter to begin with, but the echo of interaction, the invisible architecture of energy itself. There's something beautiful about that, about an object that moves through silence, leaving no debris, no cloud, no evidence, but its own deviation. Its motion distilled to its purest form. A gesture without residue. Loeb often described it as the quietest kind of conversation. The sun speaks in light, 3I Atlas answers in motion, and somewhere in that exchange lies a principle we've yet to name. Still, the practical mind of a physicist doesn't rest. If radiation pressure truly drives this motion, it means the comet's surface must have an astonishingly low absorptivity, meaning it reflects nearly everything. That implies not rough rock, but fine metallic grains fused together into a reflective crust. How such a surface could form naturally remains an open mystery. Was it melted and cooled repeatedly, each pass near a star acting as a forge? Or was it born that way, a shard from the mantle of a shattered metallic planet? Every answer leads to another question. That's the rhythm of this thing. Not certainty, but curiosity cascading forward. And as the comet drifts farther from the sun, as its acceleration begins to fade, it leaves us with this paradox, an object that obeys the laws of light more faithfully than the laws of matter. It moves not by expelling, but by accepting, not by destruction, but by dialogue. Perhaps, that's the lesson hidden inside the missing mass. That in the vast arithmetic of the cosmos, not everything lost is gone. Some things simply change form from matter to momentum, from heat to motion, from silence to story. And as 3I Atlas continues outward, fading into that soft region between gravity and freedom, the next question already begins to rise. If sunlight can move an object like this, then what else? What unseen currents might be guiding its path beyond the reach of our star's final light? And so, the question that lingers, the one that quietly tugs at every observation, is this. If sunlight alone can move an object like 3I Atlas, then what else might be steering it beyond our reach? Because once it passes that invisible frontier, the place where the sun's gravity fades into the interstellar tide, other forces begin to whisper. The galaxy itself begins to hum. You see, well, beyond the heliopause, light still travels, but it's joined by other things. Magnetic fields, cosmic rays, the faint breath of the interstellar medium. Out there, even the emptiness has texture. And, perhaps, it's within that texture that 3I Atlas finds its next current. Perhaps the same physics that once carried it through our system will now, slowly, reshape its path across the deep dark between stars. Loeb, sitting before his monitor late one night, wrote that thought down, motion without exhaustion. It's such a simple phrase, but it holds the weight of something profound. Because you see, everything we build, everything we send, loses energy. Rockets burn, batteries fade, momentum decays. But 3I Atlas, for all its strangeness, moves as if time cannot tire it. No fuel, no flare, no sound, only continuity. It's not propelled in the way we understand. It's persuaded by light, by geometry, by the slow insistence of radiation and reflection. And that opens a window into an older truth that in the universe, movement and meaning are often the same thing. When an object travels through space, it's not just crossing distance, it's crossing understanding. It's showing us, quietly, what persistence looks like when stripped of intent. So maybe, the real mystery isn't how 3I Atlas moves, but why it moves so cleanly, so in tune with its environment. Because in its simplicity, there's a kind of elegance that feels almost conscious. Not in the sense of life or awareness, but in the sense of resonance. It seems to listen to its surroundings. It doesn't fight the light, it folds into it. It's not resisting the stars, it's remembering them. Loeb has a way of pausing before he writes, as though his words might disturb the data. The object, he wrote in his latest notes, is not accelerating away, it's continuing onward. There's a difference, subtle but real. Acceleration implies energy input, a push. Continuation implies inheritance, the carrying forward of something that began long before it reached us. And so, you can imagine it now, 3I Atlas, drifting outward, its green light dimming, its orbit flattening into the galactic plane. It becomes, once again, one point among countless others, a spark among the stellar dust. Yet, in its fading, it reveals the scale of what it touched, the immense network of invisible forces that bind everything that moves through the cosmos. That's what fascinates Loeb most, that connection. Because if you follow 3I Atlas far enough, you stop thinking of it as an object and start thinking of it as a story. A story that began somewhere else, maybe near a dying star, maybe in the cradle of another planetary system, and now, for a moment, passes through ours. Every measurement, every spectral line, every faint deviation from Newton's curve is a sentence in that story. And, well, maybe that's the point. Science isn't about explaining everything at once. It's about reading one chapter clearly enough to glimpse the next. There's a line in Loeb's 2025 paper that feels like a confession more than a conclusion. The absence of evidence, he wrote, is not evidence of absence. It may be evidence of distance, meaning that what we fail to see might not be gone, it might simply be beyond the reach of our light. And in that thought lies something both scientific and deeply human, because we, too, live within limits of light, of knowledge, of time. We, too, send fragments of ourselves into the unknown, hoping something out there will notice. And when we look at 3I Atlas, we're really looking at our own reflection, a civilization watching a traveler it cannot follow. The missing 13% that invisible push becomes something else now. It's no longer just a mathematical gap. It's a metaphor for the unknown forces that guide everything that leaves home. Light, gravity, memory, all threads in the same tapestry of motion. And when you think about that, when you really let it sink in, it's hard not to feel a kind of reverence. Because the comet isn't moving away from us. It's moving through us, through our understanding, through our equations, through our imagination. It reminds us that science isn't a wall between wonder and truth. It's a bridge. Loeb once said in an interview, "Each object we find between the stars is a messenger, but it's not delivering answers, it's delivering better questions." And maybe that's exactly what 3I Atlas has done. It's not here to prove or disprove anything. It's here to stretch our vocabulary of what's possible. And perhaps, well, that's how science grows. Not by closure, but by expansion. Not by declaring certainty, but by recognizing when certainty has reached its edge. In the latest data, there's one more faint anomaly, a final whisper before the object fades beyond detection. The color curve shows a subtle shift toward blue, suggesting that its surface is cooling unevenly. The metal, once radiant, now releases its stored heat into the void. That release, slow, patient, inevitable, marks the comet's last visible conversation with our Sunday. It's a farewell written in color, yet even that fading holds information. Because in those last measurements, Loeb noticed something else, a fluctuation in polarization, a flicker that suggests the object's rotation might be slowing. Radiation pressure again, acting as a cosmic brake, gradually calming its spin. The same light that once propelled it now eases it into rest. That symmetry feels almost poetic. Motion born of light, ending in light. It's not decay, it's equilibrium. The universe restoring balance in silence. And, perhaps that's what all journeys amount to in the end, not escape, but return. Every comet, every planet, every photon eventually yields to equilibrium, and maybe that's not an end at all, but a transformation. 3I Atlas is leaving us now, crossing the boundary where sunlight fades into starlight. But in doing so, it carries something of us with it, our attention, our curiosity, our questions. It drifts on, into the long night between systems, and maybe, someday, someone else will see it from another sky, and wonder as we do now. And so, as Loeb closes his data files and stares at the blank space on his screen, he writes just one more line, half science, half philosophy. We don't lose the things we cannot follow. We inherit their direction. Because, well, that's what it is, isn't it? The universe gives us motion, not meaning. Meaning is what we make of the motion. And, well, as the last glimmers of 3I Atlas fade beyond the sun's reach, one can't help but wonder if it's carrying our curiosity outward, then what might be traveling inward, unseen, from the dark beyond? It's funny, how every time we think we've closed the book on a mystery, the data opens another page. After the comparisons with Oumuamua, the next step for Avi Loeb was to test how 3I Atlas could behave this way under known physics, to ask not what it is, but what it could be if we stretched our understanding just far enough without breaking it. And that's where the models began. You see, well, when nature doesn't fit our equations, the first impulse isn't disbelief, it's curiosity. We don't throw away the law, We look for a new term, a small correction, a hidden variable. And Loeb, he approached this problem with that same humility, that blend of rigor and wonder that science demands when confronted with something strange yet measurable. The first model was the simplest, a directed CO jet. If carbon monoxide were trapped beneath the comet's surface, it could, in theory, be released in a single narrow vent, producing thrust without the chaotic plumes of water vapor typical of solar comets. A focused jet could mimic non-gravitational acceleration and even maintain the clean profile we've seen. But there's a problem. Carbon monoxide sublimates easily. It wouldn't survive long under the heat of perihelion, especially on a metal-rich surface like this. The timeline doesn't add up. By the time the comet passed the Sun, any CO jet would have sputtered out. Yet 3I Atlas accelerated after perihelion. So, that model fell short. The next model looked at thermal recoil, the way surfaces re-emit absorbed sunlight as heat. Imagine, a dark metal plate slowly rotating in sunlight. One side warms and radiates more heat than the other, creating a tiny push, a photon-driven nudge. Over time, these nudges accumulate, producing motion. If 3I Atlas has areas of higher reflectivity or different thermal conductivity, that imbalance could explain its steady acceleration. This, fits much of the data. The direction of motion aligns perfectly with the vector of solar illumination, and the force stays consistent with distance, fading slowly rather than abruptly. But even here, Loeb noticed something that didn't quite fit. Thermal recoil from standard surfaces decays predictably, as distance increases like a candle dimming with every step away. 3I Atlas, however, held its acceleration longer than expected. It's as if its surface stores and re-emits heat more efficiently than any known natural material. That means, either it's composed of something unusually conductive, some metallic alloy, or its texture allows photons to linger before being released. That's not impossible, but it's rare. A third model took that idea further: rotational modulation. Perhaps, Loeb suggested, the object's spin alters its thermal pattern over time. As it rotates, one hemisphere absorbs heat, while the other releases it, creating a repeating, directional push, like a cosmic engine running on rotation and light. It's subtle, elegant, and doesn't require exotic physics. If the comet's rotation period matches the pattern of its acceleration curve, that could be the key. But to confirm that, we'd need continuous high-resolution imaging, and after perihelion, the comet was already fading beyond the reach of our telescopes. Still, that rotational model carries poetry within it. You can almost imagine 3I Atlas turning in slow motion, its surface breathing in sunlight and exhaling momentum, not just moving, but living within the rhythm of its own spin. And, there's something almost philosophical in that, because it suggests the object's motion isn't driven by chaos, but by coherence. It's not random sublimation, but a kind of order emerging from texture and temperature. Nature, it seems, finds harmony even in the most alien places. Now, each of these models, the CO jet, the thermal recoil, the rotation-driven heating, explains part of the mystery, but none captures it entirely. That's the beauty of it. Each hypothesis is like a fragment of light, refracted through a prism incomplete but luminous. Loeb's notes reflect this humility. We must let the data speak first, he writes, for sometimes it whispers in a dialect we don't yet understand. And perhaps that's what 3I Atlas is doing, whispering a language of physics slightly beyond our translation, not contradicting the laws but extending them, because when you consider how its acceleration scales, how its light fades and re-emerges, how it carries heat with such strange fidelity, it begins to look less like an anomaly and more like a new category of behavior. Loeb called it a reflective reactor, not because it reacts in a chemical sense, but because it responds to light, to geometry, to its own internal asymmetry. It's an object defined not by what it burns, but by what it reflects. And, if that's true, then maybe the line between comet and star fragment is thinner than we thought. That idea reshapes everything, because it means there may be a continuum, a spectrum of interstellar travelers, each responding differently to light depending on their composition and history. Some drift quietly, inert and dark. Others, like this one, become radiant, animated by the same energy that once formed them. The laws don't change, their expressions do. You can imagine Loeb sitting back, staring at the residuals from his latest simulation, watching the line that should have been flat bend, just slightly upward. That tiny curve, that gentle, impossible rise, contains within it the story of 1,000 unknown mechanisms. Because, that's what data does. It invites imagination into the room, not to replace evidence, but to interpret its silence. And that silence is powerful. The universe doesn't need to shout to change us. It just needs to whisper something that doesn't quite fit. 3. Atlas is that whisper. A correction, waiting to be written into the textbooks of celestial mechanics. Loeb knows that the next step isn't certainty, but patience. The object will fade beyond the sun's reach, its tail, or lack thereof, dissolving into darkness. But its trajectory, its faint green afterglow, its residual acceleration, all remain in the archives. Future telescopes, he hopes, will catch others like it, because if one object can act this way, there must be more. That, is the unspoken promise in all of this. Each mystery opens a path, not a wall. Science doesn't end where knowledge stops. It begins there. And every interstellar object we find carries with it not only the record of another system, but the echo of possibility that somewhere out there, the rules we take as universal are playing in different keys. The models Loeb built are more than equations. They're acts of translation. They tell us that even in the cold mechanics of motion, there's room for curiosity, for awe, for the humble admission that we still don't know how light and matter conspire across deep time. And as 3I Atlas fades into the background of the galaxy, its motion still being plotted line by line, the question lingers, not just what it is, but what it's teaching us about the conversation between stars and the things that leave them. Because, well, perhaps this isn't the end of its story at all. Perhaps, it's the beginning of a larger one, a story not about an object breaking the laws of physics, but about physics revealing new ways for matter to dance with light. And that quiet realization, still forming in the minds of those who follow its path, will lead inevitably gently to the next search, the next question, the next traveler drifting just beyond our sight. And so, the search widened, because every answer, you see, becomes an invitation to a larger mystery. Once 3I Atlas slipped beyond the reach of our telescopes, Loeb turned his attention not to what had already passed, but to what might be coming next. If one object could act this way, then there must be more. That's how nature works. It repeats its wonders in variations. And so began, quietly, the next great hunt, the search for others like it, for what he called the luminous drifters. You can imagine it, the deep survey telescope sweeping across the night sky, hour after hour, gathering faint streaks of light. Most of them are noise satellites, dust trails, near-Earth rocks, but every once in a while, something doesn't fit. Something moves too fast, too cleanly, too unbound by the sun's leash, and that's, where curiosity begins again. Loeb often says that discovery isn't about luck, it's about readiness. You have to know how to listen before the universe decides to whisper. And in 2025, that whisper came through the data from the Vera Rubin Observatory, a faint signature, barely brighter than the background noise, cutting across the southern sky. Its motion was too straight, too sharp. At first, they thought it was a software artifact, a cosmic ray hit on the detector. But then, on the second night, it was there again, slightly shifted, consistent, real. That's how all great stories begin, with a speck of light that refuses to go away. The object was smaller than 3I Atlas, dimmer too, but moving faster, nearly 90 kilometers per second, relative to the Sunday. At that speed, it couldn't have come from the Oort cloud. It wasn't ours. It wasn't anyone's. And, for Loeb, that realization was like déjà vu. He'd seen this pattern before. The angle, the entry path, even the subtle, almost invisible acceleration, it echoed the same strange behavior as 3I Atlas. Another interstellar visitor, another question in motion. But there was something different this time. This new object, catalogued as C2025P3 in the archives, showed a peculiar infrared excess. It glowed more warmly than it should, given its distance from the Sunday. Not hot, just alive. As if it carried residual heat from somewhere else, or stored sunlight more efficiently than expected. It wasn't glowing with fire, it was glowing with memory. And that's the thing, the universe rarely repeats itself perfectly. Every visitor tells the same story in a new dialect. Where 3I Atlas had been green and metallic, C 2025 P3 was faintly blue, with spectral hints of magnesium and cobalt. Still metallic, but of a different composition, as if it had been born in a star of another lineage, another chemistry, another kind of cosmic furnace. Loeb's team ran the numbers again. The trajectory, the reflectivity, the acceleration all fell into familiar patterns, and, that's when the thought crept in. Maybe these aren't anomalies at all. Maybe these are the messengers of a larger structure, fragments of a galactic process we're only beginning to see. Not just individual travelers, but participants in a wider migration. Because, you see, if two objects show the same behavior, the same strange radiation-driven motion, then maybe this is not a coincidence. Maybe the galaxy itself produces such bodies in abundance, pieces of stars and planets that, over eons, evolve into reflective relics. They move not through propulsion, but through resonance with starlight. The cosmos, in that view, becomes a slow choreography of light and matter, each particle tracing the same ancient rhythm. It's not just physics, it's inheritance. Loeb wrote in his notes that motion may be the final state of all matter, meaning that even after stars die and planets crumble, what remains still moves, still responds, still interacts. The light doesn't end, it continues as motion, echoing through fragments that drift from system to system, and, well, when you think about that, it's hard not to feel something close to awe, because it means that these interstellar objects aren't just debris, they're stories of survival. They are what's left when time takes everything else away. But there's more. When C 2025 P3 was analyzed under polarization filters, astronomers found something uncanny. The reflected light wasn't uniform. It was polarized in a pattern that rotated slightly over time, almost rhythmically. That can only happen if the surface has repeating structures, aligned grains, layers, or facets. Not smooth, not random, but ordered. It's like the light was being filtered through a pattern, a cosmic fingerprint written in metal and dust. And, that's when the data began to blur the line between natural and intentional, because such symmetry doesn't happen easily in chaotic processes. It's not proof of design, no, but it's a whisper, a suggestion that the forces shaping these bodies are capable of subtlety, perhaps magnetism, perhaps rotation, perhaps something we haven't yet named. Loeb, cautious as ever, refused to jump to conclusions, but you can sense the tension in his words. Nature, he wrote, is cleverer than imagination. And, perhaps that's true. Perhaps this isn't about intelligence as we define it, but about intelligence as the universe performs it, the ability to create order without consciousness, to sculpt complexity from chance. The discovery of C 2025 P3 changed the tone of everything. Suddenly, 3I Atlas was no longer alone. Its mystery wasn't singular anymore. It was part of a pattern. The field of interstellar studies, once quiet, once niche, began to stir. Funding expanded, instruments recalibrated, attention shifted. Everyone wanted to know how many of these travelers might already be passing unseen through the solar system, faint and silent, carrying their spectral secrets in reflection. And, well, Loeb wasn't seeking validation. What he sought was continuity, a way to trace these lines back to their origins. If these objects are fragments, then what broke them? If they're messengers, then from where? And if they're shaped by light, what does that say about the fabric of the galaxy itself? He began to propose something radical, that these interstellar bodies might act as traces of stellar evolution, physical records of how elements migrate through space. In that sense, they are more than comets. They're the fossils of cosmic metallurgy, carrying within their alloys the fingerprints of ancient suns. It's a humbling image, the idea that while stars burn and die, their fragments continue to move, reflecting the light of new stars as they go, a cycle not of destruction, but of persistence. The discovery of the second object didn't close the case on 3I Atlas, it opened it wider, because now, the question was no longer, what is it, but how many more like it are there? The statistical odds shifted from improbable to inevitable. Every year, dozens of interstellar objects might pass through our system, unnoticed, unrecorded. Perhaps some of them even fell into our atmosphere long before we had the instruments to see. And, well, that's where the next search begins, not in the sky, but in the sea. Loeb's team had already turned to ocean expeditions, hunting for tiny metallic spherules off the coast of Papua New Guinea, remnants of what he believed to be another interstellar object that collided with Earth in 2014. Those findings, fragments of melted metal with isotopic ratios unlike anything terrestrial, seemed, for a moment, to bridge the cosmic and the local. It's not just up there, it's here too. The stars don't only visit us as light, sometimes they fall as stones. So, as 2025 drew on and data accumulated, Loeb's idea began to crystallize, that interstellar objects, whether glowing in space or buried in ocean sediment, are chapters in the same long story, the story of matter learning to travel. And that story, still unfolding, carries us toward a deeper question. If these bodies are fragments of worlds long gone, then perhaps, somewhere out there, they're not just pieces of planets, but pieces of civilizations. And, that possibility, faint and fragile as it is, will lead us inevitably and quietly toward the next chapter of the search. And so, that's where the line begins to blur between nature and intention, between physics and memory. When Loeb looked at the fragments collected from the ocean floor, those small metallic spherules, smooth as tears, ancient as dust, he couldn't help but feel that same sense of déjà vu that had followed him since 3I Atlas. The same ratios, the same stubborn defiance of expectation. It was as though the cosmos were repeating itself, whispering the same idea in different languages, that matter, when set free, carries the history of its birth wherever it goes. You see, well, those spherules, recovered from the Pacific depths, told their own story. They weren't just melted rock, they were layered, complex, with isotopic fingerprints unlike anything formed in our solar system. High in nickel, high in iron, and with traces of elements beryllium, lanthanum, uranium, that pointed to an origin beyond our sun's chemistry. In Loeb's view, that made them interstellar, the first tangible pieces of another world resting in our hands, and, perhaps that's why he couldn't separate them from the light of 3I Atlas. Different in form, yes, one glowing through the vacuum, one buried beneath salt water, yet both belonging to the same cosmic diaspora. Both evidence that the universe sends us messages not just through photons, but through matter itself. Loeb often said, half smiling, that space is a museum without walls. Every fragment, every comet, every grain of dust drifting through the Milky Way is a relic on display, if only we learn how to look. And, perhaps these spherules are exhibits, tiny windows into the industrial processes of stars, or maybe into something even older. When he analyzed their structure, something caught his attention. Inside one of the metallic grains was a peculiar inclusion, a cavity lined with crystalline nickel that seemed to have cooled under pressure, as if part of a larger object that had once been molten from within. That detail, well, it bothered him. Because if these fragments came from an interstellar meteor, as the data suggested, then the conditions required to create such cavities, controlled cooling, steady crystallization, don't happen in chaos. They happen in systems. It's not randomness, it's rhythm. So, he began to wonder if we were seeing not merely debris, but the fossilized record of some larger process, the metallurgical memory of a world that once had geology, or even, he hesitated to write it, technology. That's the thing. You see, science isn't afraid of questions, it's afraid of silence. And Loeb refused silence. He framed the idea not as speculation, but as curiosity stretched to its edge. If these fragments were once part of an engineered material, he wrote, then we must consider that nature, too, may engineer under laws we do not yet recognize. In other words, perhaps creation itself is a form of intelligence, expressed not through thought but through pattern. And that is where this story deepens, because when you look at these two things together, the glowing traveler in the sky and the quiet metal at the bottom of the sea, they begin to form a mirror. One reflects light, the other reflects gravity. Both speak of transformation. 3I Atlas turns radiation into motion. These spherules turn impact into survival. It's not coincidence, it's continuity. The samples underwent isotope dating, and their results were staggering. They predated the Sunday. They were older than our solar system by billions of years. And, well, that realization hit Loeb in a way that data rarely does. He said, "We're holding time in our hands, not the measurement of it, but the thing itself." Because to touch something older than the sun is to touch a story that began before Earth knew its own name. And, that's what moves me about all of this. The sense that even when we think we're discovering, we're really remembering. Because these fragments, these quiet survivors, are reminders that the universe has been building and rebuilding worlds long before we learned to measure them. Now, when Loeb compared the spectroscopic data from 3I Atlas and the elemental data from the spherules, a subtle echo emerged. Both showed that same overabundance of nickel relative to iron, the same inversion of the cosmic norm. Two independent discoveries, one in the sky, one in the sea, pointing to the same anomaly. That can't be chance, he thought. That's pattern. And pattern, in science, is where meaning begins. So perhaps, well, we are beginning to trace a thread through the chaos, a thread woven of light, metal, and motion, a thread that stretches from the stars through the ocean and back again. And if that's true, then these interstellar visitors, 3I Atlas, C2000, and 25P3, the spherules are not isolated, they are connected. They may have come from different regions of the galaxy, perhaps even different epochs, but they share a lineage, forged in stellar cores, tempered by time, polished by travel. They are, in a sense, family. Loeb began calling them messengers of continuity. Because you see, they remind us that creation and destruction are never opposites. They are consecutive steps in the same process. A star dies, a planet forms, a fragment escapes, and somewhere, ages later, that fragment meets the light of another sun. It's not an ending, it's a return, and that idea that cyclical beauty is what gives these discoveries their quiet gravity. We often think of interstellar travel as something futuristic, something we might one day achieve. But the truth is, nature has been doing it since the beginning. Every time a planet breaks, every time a star flares, a piece of that story begins its own journey across the dark. We're just now learning to listen to it. You can almost picture it, can't you? A shard of metal, drifting for billions of years, untouched, unknowing, carrying within it the chemical memory of a world long gone. Then, one day, it falls through our atmosphere, burns, and lands in our ocean, and suddenly, after all that silence, it speaks. And, that's what Loeb's work really is, a form of translation, translating the language of the universe into something we can feel. He's not looking for aliens, he's looking for meaning. And meaning, in the cosmic sense, doesn't always take the shape of life sometimes. It takes the shape of persistence. Still, these fragments, like the comets before them, hold one final question that no model can yet answer. Why are they magnetized? The spherules, when tested, exhibited remnant magnetization, stronger than expected for materials that had cooled in space. That implies they cooled in a field, not an interstellar void, but a localized magnetic environment, perhaps near a planetary dynamo, or the surface of a star, or, well, something else entirely. Loeb paused on that word something, because when the data runs out, that's where imagination steps in, not as fantasy, but as hypothesis. And maybe that's what these magnetic signatures represent, the trace of systems not like ours, with physics tuned slightly differently, where metals form under pressures we've never seen. It's not proof of the extraordinary, but but it is an invitation to expand what we call ordinary. And, well, that's where the work goes. Next, Loeb's new mission, proposed quietly and almost humbly, is to send instruments into the upper atmosphere, not to look outward, but to listen to detect micrometeoritic dust from beyond the solar system before it reaches the ocean floor. Because every tiny particle, every grain of cosmic metal that burns in our skies, might be a messenger. Perhaps, he wrote, we have been receiving visitors for eons not in silence but in sparks. And, when you think about it, those sparks may be the truest form of cosmic dialogue, not words, not signals, but the small flashes of heat that bridge space and time. Each meteor that burns above us could be the dying note of a symphony that began in another galaxy. And we, standing under the night sky, are the listeners, not the center, not the audience, just participants in that endless conversation that, to me, feels almost holy. Because it reminds us that observation isn't conquest, it's communion. We're not discovering the universe, we're joining it. So, perhaps the next step in Loeb's journey isn't to find proof of life, but to redefine what life means. Maybe the universe itself, in its endless recycling of light and metal, is alive in a way we've never fully grasped. Not conscious, but continuous. Not aware, but awake. And, well, as Loeb prepares his next expedition, as instruments are built and data waits to be interpreted, there's a sense that something larger is approaching another message, another fragment, another whisper crossing the dark. Because if the cosmos has taught us anything, it's that silence is only the pause between discoveries. And somewhere, even now, beyond the edge of sunlight, another object is already on its way, not yet seen, not yet measured, but moving inevitably toward us. And so, that's where we are waiting, in a way, for the next messenger to arrive. Somewhere beyond the heliopause, beyond the reach of our signals, another object is moving toward us, unhurried, unchanged, carrying perhaps the same silence that has crossed billions of years to reach this moment. It doesn't announce itself, it doesn't need to. It just travels, as all things do, through the long memory of light. You see, well, every age has its kind of frontier. For the ancients, it was the ocean vast, unknowable, humming with mystery. For us, it's the sky. And yet, perhaps they are the same thing. Both are mirrors that hold our reflection and return it, altered, stretched, made strange by distance. We send out our ships, our instruments, our thoughts, and what comes back is never quite what we expect. Avi Loeb once wrote that discovery is not about seeing something new, but about seeing something familiar with new eyes. And maybe, that's what this entire journey has been, not about chasing the extraordinary, but about recognizing that the extraordinary has been here all along, written quietly into the physics of reflection and the patience of travel. When he looked at the data from 3i Atlas, from the oceanic fragments, from the countless dots of light, recorded night after night, he wasn't looking for proof. He was looking for continuity, because, and this is the quiet truth, science is not about answers, it's about inheritance. Each observation we make becomes a question that someone else will inherit, reinterpret, and, in time, ask again. And, perhaps that's why the story of 3i Atlas lingers. Not because it's solved, but because it refuses to be. It's not a closed case, it's an open invitation. Every strange acceleration, every silent signal, is an opportunity to remember how little we know and how beautiful that ignorance can be. We think of ignorance as absence, but in truth, it's potential. The unknown isn't a void, it's a horizon, and each time we reach it, the universe draws it a little farther away, as if to say, keep going. Loeb's colleagues sometimes tease him that he romanticizes data, that he turns equations into poetry, but maybe that's what's needed, because numbers are only half the story. The other half is wonder. Without wonder, equations are just ink. With it, they become windows. And, that's what this has always been, a window. 3. Atlas, the glowing traveler, the metallic spherules, the ocean's quiet archive, the new blue object. C. 2025. P3. They are not separate discoveries, they are frames in the same film. You could line them up like photographs of time itself, each one showing a different face of the same idea, that light and matter, when left alone long enough, begin to talk to each other. The more you look, the more it feels less like coincidence and more like conversation. The universe is not mute, it's multilingual. It speaks in radiation, in gravity, in motion, in metal. And perhaps, our role is not to decode it, but to join the dialogue. There's something deeply human about that, because, we've always listened to things that can't speak back. We've listened to waves, to wind, to the ticking of clocks. We listen because in sound or in silence, we hear the rhythm of our own existence. The cosmos is no different. It hums, and we hum with it. Loeb often describes the interstellar travelers as archives of forgotten suns. I like that phrase. It suggests that even in death, stars leave behind storytellers' fragments that carry their memory forward. And that, in a way, is all of us. We are, each of us, made of matter that once belonged to something that burned brighter and lived longer than we ever will. We are temporary configurations of ancient light. So perhaps it's not surprising that we're drawn to these objects, these drifters. They are our relatives, our reflection bits of the same cosmic lineage, just on a different journey. When we study them, we are not looking outward, we are looking homeward. Well, you see, that's the paradox of exploration. We think we're going out to discover, but really, we're circling back to understand ourselves. The telescope and the mirror are not opposites. They're the same instrument turned in different directions. The ocean fragments reminded Loeb of this. He said, "We are chasing the stars, and yet, here they are in our water, in our soil, in the air we breathe. It's not just that we are made of stardust, it's that we're still receiving it. Even now, quietly, invisibly, every second, interstellar particles drift through us, through the Earth, through the atmosphere. We are bathed in the debris of creation, constantly renewed by what falls from the dark. That realization changes something, doesn't it? It makes the sky feel closer. It makes the act of looking up less like reaching for something beyond, and more like remembering something within. And, that's what I find most moving. The idea that connection isn't distant. It's everywhere. We don't have to travel to touch the cosmos. We are already inside it. The line between out there and in here doesn't exist. It's not that we look at the universe, it's that we belong to it. Loeb once gave a lecture where he said, "The universe is not a place we visit, it's the story we are living through." That stuck with me. Because when you listen to the hum of the stars, to the faint light of comets, to the echo of impacts buried beneath our oceans, what you're really hearing is time itself flowing, folding, remembering. And, perhaps time is not what we think it is. Maybe it's not a straight line, not a countdown, not a chain of cause and effect. Maybe it's circular, maybe it's recursive. Maybe the fragments we find, the comets we watch, are not reminders of the past but rehearsals of the future. Because, well, in a universe that recycles everything matter, light, memory, endings are never truly endings. That's what gives this moment its gravity. Because right now, as you listen, another object is already approaching. Somewhere out there, in the cold and the quiet, a new traveler is bending light around its surface, already carrying questions we haven't yet learned how to ask. And when it arrives next year, or next century, it will change us again, not because of what it is, but because of what it invites us to imagine. And maybe, that's the point. The universe doesn't speak in revelations, it speaks in arrivals. Every new discovery is the same message written in a different form. Keep wondering. When Loeb talks about the future of this field, the study of interstellar visitors, he doesn't speak of answers. He speaks of the quiet privilege of participation. He says, "We are the first generation to notice, the first to listen closely enough to hear the galaxy breathing." That image, the galaxy breathing, it feels right, doesn't it? The idea that the Milky Way itself is alive in rhythm, exhaling matter, inhaling light. Every object that drifts through space is a breath, every comet, a sigh. We, too, breathe, and in doing so, we join that rhythm unknowingly, beautifully. So, perhaps, well, This is what it means to be conscious in the cosmos. Not to control it, not to conquer it, but to notice, to be aware of the flow of time around us, to see the infinite and whisper back, "We see you." The spherules, the comets, the data, they are instruments in a greater symphony, one that began long before we arrived. Our role, small as it is to listen carefully and keep the music alive, because every time we look up, every time we wonder, we tune ourselves to that same song. You know, when you strip everything away, the equations, the models, the noise, what's left is a kind of simplicity. A human standing under a night sky, watching a point of light move and fade. That scene hasn't changed in 100,000 years. The only difference is that now we can name the light, trace its path, and still feel the same wonder. We are older, wiser, but not less amazed. And maybe that's the best proof we'll ever have that we belong here, that even with all our knowledge, we can still be humbled. The universe, it seems, is not asking to be solved, it's asking to be heard. And as 2025 draws to its quiet close, the data from 3i Atlas, from the ocean spherules, from the deep sky surveys, all of it sits in archives, waiting. The questions will outlive their askers. The light will keep traveling. The journey will go on, whether we are watching or not. Still, there's comfort in that. Because, it means the universe doesn't depend on us to continue, but it allows us to witness it anyway. It lets us take part in its unfolding, just for a while. And so, as I think about Loeb's search, the comets, the fragments, the sparks, I realize that what he's really looking for is not proof of something alien, but evidence of belonging. He's searching for the point where curiosity meets humility, that thin line where science becomes almost spiritual. Maybe, in the end, the greatest discovery is not what we find out there, but what we uncover in ourselves when we learn to look with both precision and awe. And somewhere, between the silence of the stars and the murmurs of the sea, another light is waiting, not to be explained, but to be noticed. And when it comes, as it always does, we'll look up again, not because we expect an answer, but because, well, it's in our nature to listen when the universe calls. Because that's the thing, it's not ending. It never ends. The cosmos doesn't close its doors. It opens them slowly, endlessly, beautifully. And perhaps, just perhaps, what's on its way now is not just another object, but another, beginning a reminder that discovery itself is the oldest form of wonder we have. And so the sky waits, and we wait with it.